Hello, in today's video we're going to be discussing a third method of solving systems of linear equations. In section 5.3 we're talking about solving systems of equations by elimination. Take a moment to refresh your memory on solving systems of equations and see what you can do with the example that I've shown you here. So pause the video and do that now. I'm going to go ahead and solve by replacing my 2x minus 1 in for my y, since I know what y equals. So I actually have 2x minus 4 times y is equal to 28, but I know that y is 2x minus 1. And then I distribute my negative 4 to get negative 8x plus 4 is equal to 28. So negative 6x plus 4 is equal to 28, subtracting 4. I find out that x is negative 4, and then I go back to find y. Y is negative 8 minus 1, so y is negative 9, giving me the solution of negative 4, negative 9. This method we spent our last few videos talking about is the method of substitution. We are replacing one variable for another, or we are substituting y with that 2x minus 1 value. So our third method is going to be elimination, and that's going to be used to solve a system of equations something like this. Now we could try and use substitution, but in substitution we either need y equals or we need x equals. In this case, in the system that we're given, I could get x by itself, I could get y by itself, but it's going to be a little bit of work. So instead, I want to use another method, and that method is elimination. The idea in elimination is that we're going to use addition to combine the two equations. So we're going to add these two together, eliminating one of the variables. So maybe all of the x's go away. That way we can solve for the other one. So for example, in this system of equations here, my first equation is x minus y is 12, and the second one is y is 4. What I can do, since the y and the 4 are the exact same thing, I can add the y to the left, and I can add the 4 to the right. Since they are equal, I'm allowed to add them to both sides. So I'm going to go ahead and add the y on this right-hand side. So x minus y plus y. This minus y and plus y are actually inverses and go away. So I have just x on the left. And on the right, I add the 12 and the 4 to get 16. So now I know that x is 16. And to find y, well, we already know that y is 4, but maybe you want to double check. 16 minus y is equal to 12, so I subtract 16. Getting a negative y is equal to negative 4, which means that y is equal to positive 4. So my solution is 16, 4. In our next example, I'm going to use elimination again. I'm going to add y to the left, so I'm going to add these two together on the left so that the y's go away, or they are eliminated. Negative y and positive 1y are opposites. So if I take away a y and add it back, they will cancel out or eliminate one another. So I'm going to add y on this left-hand side. So I've got 3x minus y plus y, those are opposites. And then on the right-hand side, I'm going to add 9. 9 plus 15 is going to be 24, which tells me that x is equal to 8. So I know that x is equal to 8, and looking back into my equation, I can have either two options. I can plug in my 8 for x and solve for y, or we can say that we already know y equals 9 because our equation tells us so. Our second equation tells us that y is equal to 9. So my solution, x is 8 and y is 9. In our next example, we have a little bit more happening, but I'm going to follow through with the same steps. I'm going to add the left-hand sides together, and then I'm going to add the right-hand sides together. Everything's lined up nicely, so when I add, I just need to add straight down. X plus x is going to give me 2 x's. But then a negative y and a positive y, these are opposites, so they go away. They are eliminated. And this equals 16. So x is equal to 8. Then I go back and I solve for y. So I will pick either one of these equations. I'm going to go ahead and pick this second equation. I know that x plus y is equal to 4. But I've already solved for x, and I know that x is 8. So 8 plus y is equal to 4. Subtracting 8 from both sides, I find that y is negative 4. So my solution, 8, negative 4. In my next example, I see a negative y and a positive y again, which means that when I add the left-hand sides together, those y's are going to cancel each other out or eliminate with one another. So that leaves me with just 4x's is equal to 24, and dividing by 4, I find that x is 6. So then I'll go back and solve for y. I can choose either the first or the second equation. I will decide to choose the second equation. So x plus y is equal to 9, but I know that x is 6. So 6 plus y is 9, and when I solve for y, I find that y is equal to 3. Go ahead and pause the video and try out these next couple on your own. Adding the left-hand side of my first system, I've got 5x. My y's are opposites, so they cancel out. And 15 plus a negative 5 is positive 10. So x is 2. Here I'll use my first equation. 2x plus y is equal to 15. 2 times 2 plus y is equal to 15. Solving 4 plus y is equal to 15, I find that y is equal to 11. So then my ordered pair, x is 2, y is 11. This is the point where, when I graph these two lines, those two lines are going to cross. My next example, I add because I see negative y and positive y, they're going to cancel, giving me 6x is equal to 30. Dividing by 6, I find that x is 5. I'll use my second equation. 2 times x plus y is 3, but I know that x is 5. And subtracting 10 from both sides, I find that y is equal to negative 7. So the point where the graphs cross is 5, negative 7. In order to use elimination, we must have what we call additive inverses. What happened in these last few examples is that when I added, two of the terms were exact opposites, and therefore they canceled each other out. That happened in every single one of these cases. So in order to eliminate, we must have those opposites. So in other words, we must have two terms that will eliminate or cancel each other out. So step 1, when solving by using, this should actually be elimination. Step 1, line up my like terms. So I've got my x's lined up, my y's lined up, then the equal sign, and then my constants. So everything's lined up. Step 2, we have to have opposites or additive inverses. So if I look at my x's, if these are opposites, then good. If not, we move on to our y's and see if we have opposites. So positive 2x and negative 2x are additive inverses. They are opposites. So step 2 is complete. So we move on to step 3, where we just add the left sides together and we add the right sides together. Negative 2x and positive 2x gives me no x's. 3y plus 2y is 5y. Negative 7 plus 12 gives me positive 5. So y is equal to 1. I'm not going to go all the way through and solve for x quite yet. I just want to get comfortable with this process first, but we will solve for x in our next one. So going back through my steps in our second example, step 1, I line up all of my terms. So x's, y's, equal, and then a constant. Step 1 is done. Step 2, I need opposites. My x's are not opposites. I've got a positive 1 and a positive 6. So when I add those, I'm going to get 7. not 0. But my y's are additive inverses, positive 4 and negative 4. So step 2 is done. Step 3, we add. Add the left, add the right. X plus 6x is going to give me 7x. Positive 4 and negative 4 means my y's cancel out. And 14 plus 0 is 14, so x is equal to 2. Now I'll go ahead and go back and solve for y. I know that x plus 4y is equal to 14. X is 2, so 2 plus 4y is equal to 14, and I can solve for y. So 4y is 12, which means that y is equal to 3. So my solution is the point 2, 3. So after we added, we then solved to find x. And after we solved to find x, we substituted and solved for y, giving us our solution of 2, 3. Go ahead and take a moment, pause the video, and practice these last 2 elimination questions. You should all be solving by elimination on your own. Since I have additive inverses with my y's, I go ahead and add, getting 5x, and on the right that equals 25 because my y's are inverses. So x is 5. So then 2 times x plus y is equal to 15. I know that x is 5. So 10 plus y is 15, which means that y is 5. So my solution is the ordered pair 5, 5. In my next and last example, I do see that the 3 x's are additive inverses. I have a negative 3 and a positive 3, so when I add, those x's are eliminated. 6y plus a negative 2y gives me 4y. And then adding on the right, 18 plus negative 10 is 8, which means that y is equal to 2. So then I go back and I solve for x. I'm choosing the first equation, but you can pick either. Negative 3x plus 6 times y, which is 2, gives me 18. And solving, negative 3x equals 6, so x is in negative 2, so my solution here is negative 2, 2. And this concludes our first of a few videos on solving systems of equations using elimination. Thanks so much for watching, and have a great rest of your day.